Today, we're going to talk about an invisible force. It's one that has guided explorers for centuries. And yeah, it's probably sticking to your fridge right now. We're diving into the surprisingly complex and fascinating world of magnets.
Okay, so to really get a handle on the power of magnetism, let's start things off with a story. And this story doesn't begin on the stormy seas, but with a writer who's kinda hit a wall. So meet Reshma. She's writing this really cool story for her grandmother, all about a trading ship in the olden days sailing from the spice-rich coast of Kerala. But she runs into a bit of a problem. Her sailors get caught in this absolutely massive storm. The sky is completely overcast, which means they can't see the stars to navigate. They are totally and completely lost. Reshma was stuck. I mean, think about it. How could her sailors possibly find their way home without any landmarks or stars to guide them? Her story had pretty much hit a dead end. So after a little bit of research, she found the solution that real sailors actually used, the magnetic compass. And this discovery didn't just save her fictional crew, it got her really curious to figure out the secret behind it.
And that's our cue. To know how a compass works, first we need to understand the magic of magnets themselves.
So the first thing you need to know is that magnets are, well, they're kind of picky. They only stick to certain materials. You can basically put everything into two big groups.
On one side, you have materials like iron, nickel, and cobalt. These are magnetic. On the other side, you've got things like wood, plastic, or glass. And those, they're non-magnetic. Now, what's really interesting is that a magnet's power isn't spread out evenly all over it. It's actually concentrated in a couple of special spots. If you sprinkle a bunch of iron filings over a bar magnet, you'll see exactly what I mean. They don't stick everywhere equally. They all cluster right at the two ends, making these cool, fuzzy-looking spikes. This shows us exactly where the magnetic force is strongest. And these ends have a name. They're called poles. Every single magnet, no matter its shape or size, has two of them, a north pole and a south pole. And here's one of the really fascinating rules of the universe. You can't have a magnet with just one pole. It's impossible. If you break a magnet in half, hoping to get just a north piece and a south piece, nope. You just get two new, smaller magnets, and each one immediately has its own north and south. These poles follow one simple, really powerful law. Opposites attract and likes repel. A north and a south pole will always pull together, but two norths or two souths, they'll push each other apart with an invisible force you can actually feel. So that one simple law of poles, that's the whole key. That's how a small magnet can become a world-changing navigational tool. This principle scales all the way up to the planetary level. Because, get this, our planet acts like one gigantic magnet with its own magnetic north and south poles. So any magnet that's free to spin will always line itself up and point in the Earth's north-south direction, every single time. This property is so reliable, you can even make your own simple compass right at home. All you have to do is magnetize a sewing needle, stick it through a little piece of cork, and then float it in a bowl of water. Just watch what happens. It'll slowly turn and point you north. And that's the secret Reshma's sailors needed. Now that you know the science, you can unlock some really fun applications. This invisible force lets you do some truly creative and fun experiments. You can use a magnet's invisible force to do all sorts of tricks, like fishing a paperclip out of a glass of water without getting wet, or guiding a steel ball through a cardboard maze from underneath. You could even build little matchbox cars that race away from each other using that repulsion force. But, with great power comes a little bit of caution. Magnets are strong, but they're also kind of sensitive, so you have to treat them with care. If you heat them or drop them or hammer them, they can actually lose their magnetic properties. Oh, and they don't play well with things like phones or remote controls. Storing them the right way is a really big deal. You should keep them in pairs, with a piece of wood in between, and make sure their unlike poles are next to each other. Putting soft iron keepers across the ends will help protect their magnetic strength for years to come. So we went all the way from a writer's problem to the fundamental laws that help run our planet. This invisible force is all around us. Not just in compasses or on refrigerators, it's at the very heart of so much of our technology. So the question is, now that you know the secret of this invisible force, what can you do with it?